Assalamu alaikum. Welcome to the course on material science, MEIE 3161. Of course, MEIE, is mechanical engineering and industrial engineering. Those are the course numbers and so on. To me, it is very unfortunate that we are starting the course in an online manner. I am a very firm believer and a very strong opinion that teaching and learning should be done with physical contact. We are together in the same class, we are doing activities together, we are discussing, you have questions, you immediately ask them, and so on. But right now, with whatever the conditions are, this is how we are going to do it. So that is how we will do, and we will upload these video lectures. And of course, you will have the class notes also, and you have the book with you, hopefully, right? So before we jump into the course, let me introduce myself. You see the picture, right? So that you at least have an idea of who is talking to you. My name is Sayyid Zahid Qamar, but in my family in Pakistan, Sayyid is the big family name. So my father, myself, my son, all of them start with the name Sayyid. So if you just call me Mr. Sayyid, then anybody can come. My father, me, anybody. My given name is Zahid, and my father's name was Qamar. So that is why I have written my name in this manner, Sayyid there. Zahid Qamar, which is my name. Sayyid is the big family name. I am a professor at the Mechanical and Industrial Engineering Department. The room number is given. The telephone is given, 1349 inside the campus. The email is given. In the department, there are 4 focus groups that all the teachers, all the professors, according to their area of specialization and according to their expertise and research, are divided into 4 areas: applied mechanics and design, dynamics and control, materials and manufacturing, and thermofluids engineering. So all your 35 plus teachers can be divided into these 4 areas. Usually one person is an expert in one area. Fortunately or unfortunately, whatever you call it, I am in both of the highlighted areas. I am in applied mechanics and design. I am also in materials and manufacturing. This means that I both teach courses in these 2 groups, and I do research and research projects and so on in these 2 groups. For example, in the applied mechanics and design side, I have taught engineering drawing for a long time. I have taught solid mechanics. I have taught creative design, which is now called product design, and so on. In the materials and manufacturing side, I have been teaching material science. I have been teaching manufacturing processes. And in both these areas, I have also taught elective courses which are in the final year and courses for masters and PhD students. So why am I in 2 groups? Normally any one person is in one group. You see, from the very beginning of my engineering, I wanted to be a very practical engineer, not what I call a desktop engineer, an engineer who does everything on his computer. I wanted to be a very practical engineer. And then after my BS, I joined the industry, worked for a few years, then went for my master's, came back, joined the industry again for a few years, then went back. So I have always wanted to be a practical engineer. So now when an engineer designs a product, any product, right? Now the design cannot be good unless it can be manufactured very strongly. So if I want to apply a lot of mechanics to my design and improve the design and come up with a very good design. So yes, theoretically I have done it, but if I do not know a lot about manufacturing, then my design will fail there. And whether I am designing or I am manufacturing, the material I choose changes everything, right? I have the same table, for example, on which you work. If this table is made of wood, then all the design calculations and the manufacturing technique will change. But if the same table is made of hard plastic, then again all the design calculations and the manufacturing techniques will change. So being a practical engineer, I design a product, I select a very suitable material for it, and then I give instructions of how to manufacture it. So therefore, and manufacturing are together. Now, this again I have never shared in a lecture before. If you go to the internet and write my name, you will find a lot of information. So some places they introduce me like this. You can read it later on if you like. But what I just want to let you know is that I have about 25 years of teaching and research experience, right, at different international universities. 25 years of this. On top of that, I have about 6 years of experience in the industry as a professional engineer. So my total experience is like 31, 32 years now. In the universities where I have studied and where I have taught as professor and so on, there is NED, University of Engineering and Technology in Karachi, Pakistan. This is the city where I was born. There is GIK Institute of Sciences and Technology, again in Pakistan. It is in the northern areas, a very specialized institute. I have been there. I have been at King Fahd University of Petroleum and Minerals in Dhahran, Saudi Arabia. I have been at Stanford University in California, and I have been at Texas A&M University in Texas. And of course, for the last 15 years plus, I am here at Sultan Qaboos University. So I have experience of teaching and learning in a lot of different universities, in different countries, different environments, and so on. During the 6 years that I was a practical engineer, I worked basically at two different industries. One was Hidada Limited in Jeddah, Saudi Arabia, and the other was Karachi Shipyard and Engineering Works in Karachi. So I started my life, practical life, as a quality control engineer. After 1 year, I was promoted to a production engineer. That was in Hidada Limited. It was a heavy fabrication industry. We did projects for, big projects for buildings and airports and so on. And in Shipyard, I joined as the deputy manager of the design department, and later on, I was made the manager of the research and development department. So why am I introducing this, right? Another thing which I just want to highlight, that I have been doing a lot of research projects since I have joined SQU. So until now, we have worked on projects in excess of $4 million. These are funded research projects from Shell, Oman, from extrusion companies, from PDO, and so on. And of course, they give funding to us to carry out research projects only if they believe that we can really do something. And I have about 200 research and technical publications, research publications in conferences and journals and books and so on. So I am doing this not to show you that, oh, I am a big person, but just so that you feel very comfortable that the person who is teaching you this course is very much a person in the basic sciences and the applied sciences of materials area, and he has used a lot of materials knowledge to design products and to manufacture products. So anytime any question comes to you, you can ask me, whether it is theoretical, whether it is about computing applications in materials, whether it is about practical applications in the industry, right? So you can be more comfortable. So let us now go to the course. There are two textbooks generally that we have been following for the last 10 years. The first I prefer is Foundations of Material Science and Engineering by Smith and Hashmi. The second book that is Material Science and Engineering and Introduction by Callister and Rethwish. So when you go to the textbook section to get them, most probably because Smith and Hashmi was a paperback, so it was not in very good condition after a few years of use, while Callister was a hard cover. So most probably you will get the Callister book. So you should ask for Material Science and Engineering Callister, and you should give your course number 3161. But if you can get hold of the older version of Smith and Hashmi Material Science, then it will be better. The lectures I have prepared initially follow Smith and Hashmi, but that is only in the chapter numbers. chapter numbers only. As far as the material goes, both are very good books, and the material in the lectures is definitely available in Smith and Hashmi. It is also definitely available in Callister, right? So there is no problem with any of these. So whichever book you see, the chapter number then that I am giving in my lectures may not be exactly the same chapter number, but if I say introduction, then go to the introduction in the book. If I say crystal structure, then go to the crystal structure chapter, and so on, and the chapter number may be different. Now this is a copy from the course outline. I have already sent you the course outline by email, and I have already uploaded the course outline in the Moodle website of the course. I have always a very funny feeling about the course outline. In the beginning, 1 week, 1.5 weeks, you keep on asking me, doctor, please send us the course outline, please upload it, until I have done it. And once I have done it, once I have uploaded it, once I have sent it to you, now any time during the whole semester till the end of the semester, if I ask you anything from the course outline, you don't know it. So you see, you keep on asking, but you usually don't go through it. That is what my feeling is, but whatever it is, right? Now this is course description, which is there on the SQU website. It does not matter, you can read it, we will go through the course anyhow. This is what you are generally very much interested in. Quizzes about 20%, practical means lab about 10%, class attendance and participation about 2%, homework assignments about 3%, midterm 25%, final 40%. So this is by rough distribution. This is how we generally conduct classes in a regular semester. In an online semester, will we be able to do the same things? I don't know, we will see, right? But roughly the distribution will remain like this. Now SQU has certain, right, A, B and C, that SQU graduates should have these abilities, A1, 2, 3, B1, 2, 3, 4, C. So you should know them, because when we decide that our course covers which parts of this, then we write SQU A1 or SQU B2 and so on. Here I have given you a course outline. This is learning outcomes, which we call learning outcome. Understand the basics of engineering materials and their role in the development of societies and industries, right? So according to SQU, this is A1, B1, B2, C. According to ABET, ABET is something which is a certification agency in the world, which certifies whether your university and your program is world standard or not. This is a matter of great pride for us here at SQU, that for the last 10 years plus, all programs in engineering have been certified by ABET. So after passing from SQU, if you go anywhere in the world, your degree is recognized worldwide, right? So these number 1 here, or A2, A3, or number 7 here, or I or J, these are ABET student outcomes, right? So of course I am not going to go through this. You can go through this, understand the relationship between microstructure and properties of materials, understand the relationship of mechanical properties of materials to strength, fracture, fatigue and creep and so on. So these are the objectives of my course, and according to SQU attributes and according to ABET, these things cover these of the things, right? So this is what it is, and we are now here giving you the weekly schedule. I'll take a very quick short break, and then I will come back with you inshallah.